Alright, welcome guys to this live coding session on model serving. And today is going to be pretty cool. We're going to build a full API to be able to serve our model and make it usable by anyone who wants to know what is the best move whenever you have a set of cards, you have a bunch of input cards that you can look at. We want to pass that to our API, and we want our API to be connected to our model so that our model can help guide anyone who's interested in playing a game of Pelote Manier. And once we have built this API, we're going to move over to the labs. And in the labs, we're going to take this API that we are serving locally and we're going to deploy it so that anyone from anywhere in the world can just use this API. So it's going to be pretty cool. I hope that you guys are excited. As always, just make sure that you have the material. If you're watching on YouTube, it should point you to the Google Drive where everything is hosted, or somewhere. Let's see if that changes. But essentially, you should be able to grab this central folder where I put all the material, and you should have access to the notebooks for today. I put all of my stuff inside of MLOps, so that's where I'm going to be able to access the notebooks. And yeah, let's get started. As always, just make sure that you are working inside of an environment that we define with conda. Here I have an MLOps environment that's going to be useful for me to build that stuff. As always, you can just do something like activate MLOps or whatever the name of your environment is, so that you can run the code that we are going to build together. So now that you have done that, if you have installed the requirements, essentially you should be able to do something like Jupyter Notebook. That's going to launch the notebook kernel, and we should be able to access the class 5 serving, right? We're not going to look into the solution, we're just going to go into the serving. And I'm actually going to make a copy of this so that I don't destroy this for other people. And well, we've done all of the hard work already. Like, we've already created in the previous modules a trained model, like a fully trained model that looks at a bunch of cards, and based on the cards that it looks at, can tell us whether we should play the hand, whether we should play the game. And this is already pretty amazing. Like, we have a fully developed solution that only needs to be deployed now so that people can use it. And that's exactly what we're going to focus on today. So the way that we're going to do that is, well, first of all, as always, we're just going to import a bunch of libraries that we need. We're going to set a bunch of options, and we are going to point our base folder to this data repository that contains all of the data that has been accumulated throughout the course. Keep in mind that all of this is still local data because we want to run the notebooks on our local computer. So that's why we keep kind of a copy of all of the data that's being generated for at least learning purposes. But essentially, all of those data by now that we've run, like we've looked into the development pipeline, the training pipeline, all of this kind of stuff, all of this data should now be centralized somewhere in the cloud, whether on BigQuery, where we can find the latest version of our feature store. In here, go back to the lab on BigQuery if you want to make sure that you understood how we got to this point here, or all of the other data that we've been storing on Google Storage, right? So that we don't keep local copy and we don't mess up the whole thing with other people collaborating on this project with us. We should have a copy on Google Storage that everybody can access, whether the feature store, the initial data that we started with, all of the models that we train and build, let's say, with MLflow, and that we manage, let's say, are here stored on the Google Storage platform. But just so that I'm able to work on a notebook and I'm able to show you in a safe environment, let's say, what can be done and how can we build an API, I have all of this data also in my local repository, especially the optimal model, the production model, the stuff that we're going to use today so that we can serve it online. We're going to focus a lot on the production model here because the last step that we want to do is take this production model and serve it so that people can use it. And so the way that we're going to do that is with the serving pipeline. As a side note, here you will see that I still have one bit of code that comes from our feature engineering. And the reason for it is that if you work in data science and if you already went through development of models by yourself, you should probably remember that all the engineering that you apply in your feature engineering pipeline All of this stuff should be applied in your serving pipeline as well, because all of the raw data that you have, let's say, and that you prepared so that you could train your model, you need to apply all of this processing on the new samples that your model is going to have to predict on, the new data that your model hasn't seen. And this is exactly what we're going to be doing today. Today we're going to generate a new hand. We're going to take a new hand with new cards that our model probably hasn't seen before, right? It's very unlikely that you have two similar hands at Belot-Manier. There's like countless of permutations of different hands you can have. So we're going to take a new hands that our model probably hasn't seen before because it's not in the initial synthetic data that the model has trained on. And we're going to provide this new hand to our model so that our model can predict whether we should play or not. And just like we had to clean some feature when we were preparing the data to be trained on the model, we're going to have to clean this feature so that the model can be served properly. And that is the reason why you have this code here, which is some stuff that you've already seen in the feature engineering pipeline. We're also keep a pointer to the feature converter because, again, just like for the feature engineering, we had to pre-process our hand by using this API. We're going to use this API for the serving pipeline as well. It's going to become more clear as we go. So let's get started with the model serving. Here, essentially, what we're going to use is we're going to use a library called Flask. Again, this is really not like an introductory tutorial on how to use Flask. I think there are like much smarter people that can explain this much better than I do. So I would definitely recommend that you go and check out Flask online. This guide is going to tell you like how to use this library, but we're going to use it in a very practical way, and hopefully it's going to become clear what we aim to do here now. As always, I put a few more resources. In case you don't want to use Flask and you want to start experiment with other libraries, you can check out the resources. You can essentially use Flask or use FastAPI or Django or anything that you want to serve your API. I'm going to focus on Flask. Well, maybe because it's one of the libraries that I know best out of the three here, and because it's very lightweight and convenient. Like it's not really too much trouble to get started with it. So essentially, I'm going to take this Flask library here, and I'm going to import a bunch of things from the application blueprint to the request library, the JSONify utility, like a bunch of stuff that we're going to be using in this module. And essentially what I'm going to do is I'm going to read one sample from our feature store. And the reason why I do this is that I just want to have access to the covariates from the feature store, right? I'm going to need to have these covariates, and that's why I'm reading just like one sample. But we're going to see as we deploy this in production, we're going to see how to do this better. But essentially, like I'm keeping the targets, the segments, and the covariates. And what I'm going to do now is I'm going to start designing the API. And the way that the API is going to work, it's going to take, let's say, a hand. And from this hand, it's going to generate a bunch of predictions. So this is essentially what we're going to be doing here. But I want you guys to have a look at how to construct the hand first. So you construct the hand by looking at the game, just like refreshing, being dealt a new hand, and compiling the 12 cards that you see here, 1, 2, 3, 4, 5, 6, 7, 8, 12, and writing with this code here, writing the hand that you have as a string. That is the input that we're going to need to provide to our API so that we can have access to the prediction. And once we have that, once we have this hand, basically we prepare a little data package here. Data package containing the hand that we're playing, who is the last bidder, who is the starting player. Oh, by the way, the last bidder here, just don't worry too much about this one. Just put something random in here for now. The starter is going to be the starting player. So for instance, here, because the AI has already played, we can infer that he's the starting player and it's our turn to play. If we refresh, for instance, well, he has played again. It's very random. Okay, so now we've refreshed and he hasn't played, so we are the starting player because we are the first one to play. So that's how you know like which one is the starting player. So here we're just going to put like a random starting player. We're going to put the contract at which we want to play. So for instance, if we're considering like we want to know whether we should play at clubs, for instance, right? We want to know if we are going to play at clubs, and if we decide to play at clubs, we want to know if we were to bet at clubs, what would be the percentage probability that the AI would tell us we would win. So essentially here we get the probability of winning for a specific contract that we play with, right? That's the whole point of the model that we've trained. And finally, we compute already the P1 phase value and P2 phase value that we have. And essentially, we compute this P1 and P2 phase value a bit manually, like if we want to play at club. So if we are asking our model, hey, should I bet at the club? Should I bet at spade? Essentially what we do here is we compute the number of points that we have based on the suit that we play in. So if we want to play at spade, then we're going to compute the points that we have at spade and all the remaining points. Again, if you want to understand how this game works, go check out a tutorial. It's going to pay off in the future when you are the only one in your group of friends who can play contract games and you can destroy everybody at bridge at a later stage of your life. Obviously, I'm thinking that you kind of have the same age as me, but anyone who's watching this, if at some point you reach the point where you play bridge, you're definitely going to have an edge if you understand how this game works. So great investment. But yeah, anyway, so you create this phase value point, 79 and 24, and once you have this data that is prepackaged, you just are missing a few more things. The last things that you miss basically are the extra features, because if you remember correctly, when we went through the feature engineering module, what we did in there is we created a bunch of more features on top of the standard features that we had. So these features were how many points do we have, how many jacks, how many nines, and a bunch of things like this. And the extra features that we created were what are the total number of points that we have in our hand and things like this. So we also need to be creating these new features for the serving pipeline as well, because this is what we've done for the feature engineering pipeline. And once you have done that, we're going to create an API route that is going to take as an input. Again, the features is just the cards that we see, right? We don't need to do anything else. The API is going to take care of converting this feature into something that the model can understand. So we just provide the hand as it is. We just provide like all of these extra information, and we're going to put our utility here inside of our API. And that's exactly what's going to allow us to serve this model, let's say, in any environment for anyone who wants to access it. And so we designed this API in the same way that we've talked about it. So if you remember correctly, this is exactly the contract that we want to set up between us, anyone who uses the API, and the server that gets some input and provide some output and interact with a database where the model, the algorithm is stored. And so essentially what we do here is we just need to create this API endpoint, this endpoint that people are going to be able to access through the web, that people are going to be able to access either through the web or through anything else. But for us, it's just going to be through the web. It's going to be much easier. And we're going to see in the labs later how we can access this endpoint that we are creating right now. But essentially, what we're doing here is we are importing Flask, the application object that allows us to create an app, and we are registering a route. We are registering an endpoint that says, hey, server, listen to this endpoint here. Check out constantly that somebody is trying to post some data. Somebody is trying to post or access some data on this route. And if somebody is trying to access something, just serve whatever the person is asking for. And in our case, the person is anyone who wants to use this model is asking for a prediction to win. That's what we want to get out of the server, out of the model. And so this function here is going to get as an input all of this data, and it's going to provide as an output all of this data. And we're going to check that out in a second. But essentially what we're going to do is we're going to run this app on a web server. So we're going to allow access to this endpoint through localhost and through the port 9000. And so our server is consistently going to listen on port 9000 to see if there is any requests that are made through the localhost. And whenever there is a request of somebody asking to use the model, what's going to happen is that it's going to trigger, let's say, a serving of this model through this endpoint here, through this serve model function. So let's see what it means in practice. Essentially what we do is we get some data. So we're going to get as an input all of this stuff here, and we need to provide as an output the predictions. So we're going to get this data, and we're going to have to handle this data, because now we are from the perspective of the server. We are in the perspective of the server who needs to handle this data, fetch the model, and apply the model on this data so that we can return the predictions. So that's exactly what you see in here. We're going to do a few things to process the data. Then we are going to go and fetch the production model so that we can apply this model on top of this data. And then the output is going to be the predictions that the person that wants to use the model is interested in. And so Essentially, everything is done locally right now because we have a local read of the model, but overall, that's exactly what we're going to try to deploy at a later stage in production, like in a real online environment. But for now, it's enough to understand more or less what we're trying to do. And essentially, what we're going to do here is we're going to get access to the data, and we're going to read the raw features from this data. We want to read these raw features from the data that we get access to. So out of the data that we have, just get the raw features. And the reason we can do that is because when people send to the server a request to get access to the model, essentially they provide data as a serialized JSON file. And so we deserialize it and we convert this whole thing into a Python dictionary. So we can act on this whole thing as though we were managing with a data dictionary. In fact, it is a data dictionary once we unserialize it. And so what we do here is we get access to the raw features, and we want to separate the raw features from all of the other information that we get from there, because we're going to have to do some processing on the raw feature. We're not really going to have to do any processing on the rest of the data. Well, first of all, like the other information that we have that are not raw features, we're going to keep that by doing something like this. We're going to iterate on this, and we're going to say keep any key and value inside of this data dictionary for each key and value inside of the data. Well, only keep them if the key, so if this guy is basically not raw features. That's how we're going to keep all of the other stuff. If k is not equal to raw feature. That's how we're going to keep like all of the other information. And now what we want to do is we want to clean these features. Like we want to turn this stuff here into something that our model is going to be able to understand. And remember, this is exactly what we did during the feature engineering part of the course. We took this stuff here and we applied a cleaning pipeline, like a cleaning process, so that we could have the hand not in its human understandable form, like we do with semantic cards and stuff like this that we understand, so that we could turn it into features that our model would be able to understand. And so this is exactly what we need to apply now to our new sample of data, so that our model, our trained model, can predict on this data what is the probability to win. And so we're going to apply this clean feature on these raw features. Essentially, that's just going to do an API call. Remember, that just does an API call to a virtual machine. This guy here, where we take the cards and we can convert them into features. So that's what we're going to apply in our serving pipeline. And now we want to build the extra features. These are the features that our model is going to need because our model was trained on these extra features as well. So that's why we want to have these extra features here computed inside of our training pipeline. And essentially, once we have this prepared, once we have our process features, what we can do is we can merge these process features with all of the other information that we haven't touched yet. Right? This is a merge that we need. And once we have that, once we have these process features, we put them into a data frame and we load the production model, and we use this production model to predict the sample, this new hand that is contained in the feature df. We use the model to predict what is the probability to win, given that we have this information here, this signal, this whole thing, let's say. And so that's exactly what we're going to do here. We're going to take our production model and we are going to do a predict proba with an S and see if we can come up with the prediction. And once we have come up with the predictions, right, we have just leveraged our model to predict what are the probability to win. Now we want to give that back to our users who are very interested in knowing this probability to win, because that's what they need to know, well, cheat and to know whether they should play the hand or not. And that's it. That's everything we wanted to do. So if we go back and we make sure that everything is run properly, and we make sure that we've reached this point where we have the data, we have the features that can be built. Now what we can do is we can launch the web server. That's going to fake the deployment of our API. It's going to pretend, it's going to look like we have deployed our API online. Now, in fact, we're kind of cheating. We're putting it online, but like, I'm going to be the only one who's going to be able to access this API. So in other words, I'm going to be the only one who's going to be able to use this API to play with and to see how the model is performing. But right now, it's good to see whether our API is working or not. And afterwards, we're going to take this API and we're going to deploy it online, like really online. But for now, let's just launch the API, and we can see that now we have a web server allowing us to make requests on localhost 9000. So this whole thing is up and running. We cannot really access localhost 9000 because nothing is really happening at localhost 9000. In fact, the only thing that's happening, if you try to do a get request of localhost 9000, nothing really is happening. Like something is telling you like, hey, we didn't find URL. We cannot really give you any data from this server if you access it that way because nothing is really defined in there. If anything, the only thing that we have defined is serve model. That's the only thing that we have defined. So the only thing that we have defined is when you access 9000 serve model, you should be able to get some data out of this. Now, the problem when we try to access this through our web browser, is that this method is not allowed. We cannot access it because here, when we have created our API and when we have registered the route that we should be able to access through this API, we've said that you could, in theory, access serve model, but you should only be able to access it if you do a post request. And when you try to access some data with your browser, essentially what you're trying to do here is a get request. So that's why you don't really get anything out of this right now. And that's also why you will see that we have a lab on Postman. We have a lab that's going to show you how to use Postman to test that your API is working properly. So I'm just going to open Postman already. You can go back later on. So this is why I am going to open Postman already. So you can go back later on to check out how the lab works more. But just keep in mind for now that Postman is just going to allow me to check whether my API has been launched properly or not, whether we can access it or not. Instead of having to do that through the web browser, I'm going to be able to do that through Postman. And I'm going to be able to see if I provide the data that my API requires me to provide. If I follow this contract here of providing the data my API wants me to provide so that I can get some data from the remote browser, the remote server, I can check whether this has been created properly. So this is exactly what I'm going to go do on Postman. And I'm going to go to this post. And essentially what I'm going to be doing here in Postman is I am going to do a post request on localhost 9000. And I'm going to access the route that I have defined here for my API to serve my model. And essentially what I'm going to do here is I'm going to send a hand. I'm sending literally a hand. Imagine I'm being dealt a new hand. I fill in the information here. I said like, hey, this is the hand that I'm playing. Please model, tell me whether I should play it or not. I just send it to my API and something goes wrong. Something is not working. 500 internal server error. So something has not been working here with my API. What is this? So trace back, blah, blah, blah. Prediction model, predict probas. A random classifier, object has no attribute, predict probas. Whoa, my old demons come to haunt me because here is exactly what I needed to do. I needed to test whether my API works properly. If I send some data, I can get some prediction out of this. And clearly something is not working. And what is not working is that probably this predict proba method doesn't have an S. Maybe it's like predict proba without an S. And so now I'm just gonna relaunch. I'm just gonna restart like the whole thing because otherwise it's not gonna let me launch the web server again. So I'm just gonna like restart this whole thing. And because I restarted, I'm just gonna rerun like everything now up to this point, up to the point where I launched the web server. All right, so now my web server is launched again, and I'm gonna go back to my Postman here to see if my API works, and I'm gonna send a request. And look at that, magic. Now it's unbelievable. Like we basically provided some data, we tell it like the hand that we want to play, and what we get back out of this API is the probability that we're gonna win. The system is complete. This is exactly what we had in mind. We have created a system where an API allows us to access some predictions from a model. And it doesn't seem like much maybe to you guys, but this is already a huge way through having this working in production. Because now the only thing that we need is for everybody to be able to access this API. And right now, this is what I mentioned earlier. Like right now, the problem is that I am the only one able to access this API because I am the only one serving this API in my local host, in my local host loop. No one else can really access this stuff. And that is exactly why we're going to need to jump over the labs here. In the lab that we're going to see, we're going to talk about Google Cloud Functions. This is going to be a very convenient tool that allows us to deploy our API that we have just created here online, so that not just me, but like anyone who has Postman installed can create this data and can get some prediction out of it, right? That's going to be what we need for everybody to be able to use this tool. And the second thing that we're going to look at is Postman, because I've just really talked about it quickly, and hopefully you can kind of understand what's the idea here of Postman, right? The idea is just that we want to replace the web browser usage by having a more consistent tool that allows us to do GET and POST requests and all this kind of stuff. But obviously you can check out the lab so that you have a deeper understanding of what's going on. Additionally, I just want to mention that we've talked about Dockerized deployments on virtual machine. And for a very, let's say, reasonable reason, I would say that I'm not a big fan of deploying a model as a Dockerized container on a virtual machine because of the reason I explained about the cost, right? Like, you don't want to have your model in a virtual machine that is making you pay for uptime. You definitely want to have something that makes you pay for runtime. I'm going to create a lab about this, but I might not be creating like a video that shows you how the lab works and stuff like this, because it's just not like something that makes a lot of sense here. But essentially, let's focus more, first of all, on the Google Cloud Functions, and that's already going to take you a long way toward completing the build of your system and having it available for everybody to use. So let's get cracking on the lab.